Okay, lesson 6, laws of logarithms. This is probably the most important stuff of logarithms we have. So again, we're going to kind of skip through the investigations. We'll cover those in class, so let's do some of these examples here. So the log law tells us if we're adding two logarithms separately, we can bring it together using multiplication. And the opposite as well. If we're subtracting two logarithms separately, we can bring it together using division. And of course, it works the other way around. It's much more common to have something using addition or subtraction and combining it using multiplication and division than going the other way around. So here, for example 1, we have evaluate the following using the product law or the quotient law. So here, these two logarithms are being subtracted. So to bring it into one logarithm, log base 2, we're going to divide. So this is log base 2 of 4. 2 to the power of what is 4? Well, 2 to the power of 2 is 4, so this logarithm must equal 2. The next one here, we have log base 6 of 9 plus log base 6 of 8 minus log base 6 of 2. So this one, what I like to think is anything that has an addition sign in front of it is going to be in the top of our fraction in our logarithm. Anything with a subtraction sign goes to the bottom. So to bring this into 1, I can say log base 6. 9 times 8 were both positive, so they go on top. The 2 goes on the bottom because it was being subtracted. So this is log base 6 of 72 over 2, which is the same as log base 6 of 36. 6 to the power of 2 gives us 36, so this also evaluates to be 2. Of course, it's not always going to be nice numbers. We're going to have to use variables here. So here it asks to use the law of logarithms to write log base 10 of x plus, log base x of 10 plus log base x of 75 minus, in brackets, log base x of 2 plus log base x of 3. So here it's being put in brackets for us, so we know that whole thing is being subtracted. So we can do this in steps, so once you get comfortable, you'll probably end up doing it in one step, but we can start by just saying, well, this becomes log base x of 10 times 75 minus, now I'm going to focus on what's in the brackets there, log base x of 2 times 3. So this is log base x of 750 minus log base x of 6. Now these two things are being subtracted, so to bring them into 1, I can go like this, 750 over 6, which 750 divided by 6 is 125, so this is log base x of 125. It's a lot simpler than what we started with. Evaluate if x is 5. Well, 5 to the power of what gives us 125? It is, sorry, not 5, it is. Okay, so next example here, log base b of 2 plus log base b of 3 minus log base b of 6 minus log base b of 8. So one way you can do it is to kind of rewrite this one like they had the last one set up for us by factoring, whoops, log base b of 2 plus log base b of 3. I'm then going to factor out a minus 1 from the last two terms. So I get log base b of 2 plus, of 6 plus log base b of 8. Well, now it's written like the question before, and I know that my 2 and 3 were being added separately, so to bring it together I'm going to multiply. The 6 and the 8 are being added in here, so that becomes our product on the bottom because of this minus sign. So we have really what is the log of 6 over 48, which simplifies to be 1/8. So log base b of 1/8. I'll leave the evaluating. Okay, example 4, the expression log base 2 of x plus log base 2 of 2x minus log base 2 of x squared minus log base 2 of y is equivalent to. So I'm going to show you just a different way of thinking of it. What I say is anything that has a positive sign in front of it, when we bring it together, if they have the same base, we can do that. When we bring it together, they're going to be multiplied on the top. anything with minus signs gets multiplied on the bottom. So that allows us to go log base 2, well, these two terms had a positive sign, so it's x times 2x, over these two had a negative sign, so they're on the bottom. So this gives us log base 2 of 2x squared over x squared y. The x squared simplify, leaving us with log base 2 of 2 over y. So we think we're done, and then we look at our answer, and it's not there. That's what happens in this unit. They're always manipulating things, changing them around. So you see, well, all of these are written as two things. So how can we split this back up some way? Well, now we're going to go the other way. This is division in the brackets, so we can change it to multiplication. Log base 2 of 2 minus log base 2 of y. Okay, that looks a little bit more like our answers. This is really saying 2 to the power of what is 2, and that evaluates to be 1. So our answer is 1 minus log base 2 of y. Determine the value of 3 log base 2 of p minus 3 log base 2 of q if p over q equals 8. So this is another quite common question. They give you something which seems unrelated, and you have to get to something similar to that expression. So the first thing, before we do anything, we need to deal with those numbers out front. So in this case, since they're both 3's, I can factor it out. That gives me log base 2 of p minus log base 2 of q. And now I can bring these two together using division. So this is really log base 2 of p over q. Tells us p over q is 8. So this is really 3 times log base 2 of 8, which is equal to 9. Okay, so the next law is called the power law, and what this allows us to do is whenever we have an exponent out front, we can bring it as multiplication. If we have an exponent on our argument, we can bring it as multiplication out front, and vice versa. So let's look at this example here. This is saying log base 4 of 16 to the power of 12. We want to evaluate it. So there's two ways of doing this. Remember, this is really asking 4 to the power of what is equal to 16 to the 12. So we could rewrite with a common base, and that would tell us that our exponent is 24. So that's one method, not too bad. If we want to use the power rule, power law to come up with this, we bring the 12 out front. So we say this is the same as 12 times the log base 4 of 16. Well, 4 to the power of 2 is 16, so this is 12 times 2, which is 24. So obviously gives us the exact same thing. This is just a more formal way of doing it. Okay, simplify the following. Log base 6 of 6 to the n. Well, same thing. This is equal to log base 6 of 6. Log base 6 of 6 is 1, so this simply equals n. And again, that should make sense because this is really asking 6 to the power of what gives us 6 to the n. Next one, 6 to the power of log base 6 of n. So again, we can first solve for log base 6 of n. Okay, sorry. So here we can make this equal to v. Then we can change to exponential form. So changing to exponential form, this becomes log base 6 of v equals log base 6 of n. So this tells us that v is equal to n. So now we can say that since this was equal to v, we can say that 6 log 6 of n is equal to n. That's the same as we investigated in an earlier lesson.